Okay, so this paper is May June 2021 6-2 Probability and Statistics. This is the first question. It says in a game of a ball is thrown and lands in one of the four slots, labeled ABCD, Raju wishes to test whether the probability that the ball will land in slot A is 1 over 4. State the null and alternate hypothesis. So I'm talking about probability being 1 over 4, although alternate being it's not equals to 1 over 4. So this would be a two-tailed test. It says the end of the ball is thrown 100 times. Probability of success is 1 over 4, and it lands. So the test statistic is 15. Use a suitable approximating distribution. So what I'm going to calculate is I'm going to calculate the probability of x less than or equals to 15. Although this is a two-tailed test, I'm just going to test the lower tail and see if this is 1% on both ends, right? So use an approximating distribution. So I'm going to have to convert this into something. I will see if I want to convert this into a Poisson distribution or a normal distribution. A normal distribution seems likely because P is very high, 25%. For Poisson, it should be lower. First, I will do the continuity correction. I will need mu, which is NP, which is 100 into 1 over 4, which is 25, and sigma square, which is NPQ. So 100, 1/4, 3/4. 18.75. So Z less than 15.5 minus 18.75 minus 25, sorry. So I get 15.5 minus 25 divided by root of 18.75. Minus So this becomes 5 minus 2.194. 1 minus 5, 2.194. So that gives me 2.194 is 2.1 and 9 and 4. So 9859. 1 minus 0.9859 is 0.0141. It's 1.41%. Okay, so 1.41%. So I'm going to accept 1.41% is greater than the 1% that I have there. So accept H naught. There is no evidence to conclude that the probability is different from 1 over 4. Okay, that was the first question. The next question says that the random variable x has a distribution this and variance of this. So first I'm going to find the variance of the binomial distribution, which is 400 into 0.01 into 0.99. 3.96. So when I'm talking about variance of 4x plus 2, the plus 2 does not impact the variance, only the 4 does. So 4 square into variance of x. Variance of x is 3.96. So I get 16 into 3.96. 63.36. It's the correct answer. It says state an approximating distribution for x, giving the values of any parameters. Justify your choice of approximating distribution. So n is large and p is small. Small means it's less than 10%. So therefore, use a Poisson approximation. With lambda np, which is 400 into 0.01, which is 4. So lambda equals to 4. It says use your approximating distribution to find the probability of 2, 3, 4, and 5. So I'm going to say e power minus lambda into lambda power 2 for 2 factorial plus e power minus lambda lambda power 3 over 3 factorial e power minus lambda into lambda power 4 over 4 factorial e power minus lambda into lambda power 5 over 5 factorial. Yeah. 2, 3, 4, 5. I get 0.1465, 0.1953, 0.1953, 0.1562. Point. Six point three three. Just rounding off error somewhere because I used my calculator to do all the calculations. Okay, then this says the random variable x takes the values in the range 1 to p, where p is a constant. The graph of the probability density function of x is shown in the diagram. Show that p equals to 2. I know that this entire area must be equals to 1. I'm going to say that half base is p minus 1 and height is p, so therefore equals to 1. It becomes p square minus p equals to 2. So I get p square, two values for p, then p equals to 2, p equals to minus 1, so I discard this. Find expectation of x. So what I'm going to need is I'm going to need the function first. This function will therefore be, this coordinate is 2 comma 2 and this coordinate is 1 comma 0. So what I'm going to do is I'm going to first construct the equation of this function. Y minus y1 then I'm going to say that x f of x on all values, so from 1 to 2, so I get 2x cubed over 3 minus 2x squared. Sixteen over 3. I seem to have made a mistake somewhere. Let me just check. I forgot 2 here. Is that the correct answer? Yes, that's the correct answer. And question number 4 says Wendy's journey to work consists of 3 parts: walking to the train station, riding on the train, and then walking to the office. The times and minutes for the 3 parts of the journey are independent and have distributions this, and this. Find the mean and variance of the total time. So total then follows a normal distribution: 15 plus 32 plus 8.6, comma 1.1 squared, 3.5 squared, and 1.2 squared. So I get a total of 55.6 and okay. If Wendy's journey takes more than 6 minutes, we just verify if I have the correct answer: 55.6 and 14.9. If Wendy's journey takes more than 60 minutes, she's late for work. Find the probability that on the randomly chosen day that she's late for work, so the total must be greater than 60. Converting this to z, I get 60 minus 55.6 divided by root of 14.9. I get 60 minus 55.6 divided by root of 14.9. 1.140. So 1 minus 0.4. 1.14 from the table is 8729. Check if I have the correct answer. I think I do have the correct answer. No, I don't have the correct answer. Uh, it's 1.104. Have I made a mistake somewhere? No, I'm fine. Oh, I was looking at the wrong answer. 0.127 is fine. Then says find the probability that the mean of Wendy's journeys times over 15 randomly chosen days. So I'm talking about the mean will be less than 54.5. So instead, now what I need is the distribution for the means. The distribution for the means is going to have the same mu, but a different variance. So I want to find out that the probable mean times is less than 54.5. So I'm going to say that 54.5 minus 55.6 divided by root of minus 1.104. So I get 5 minus 1.104, 1 minus 5, 1.104. So 8651. Okay, that was question number 4. This question number 5. It says the time in minutes spent by a customer at a particular gym has a distribution this. In the past, the value of mu has been 42.4. Following the installation of some new equipment, the management wishes to test whether the value of the mu has changed. State what is meant by type 1 errors and context. Type 1 error is rejecting H naught, which means that concluding that mean time has changed when it has not, while it is true. While it is Okay, that's what the question should say. Conclude that the population mean time has changed, although mu has not changed. Okay, the mean time for a sample of 20 customers is found to be, so the original mean is 42.4, and I want to test. So I'm going to write the null hypothesis first, then the alternate. This should be a two-sided test because I just want to test whether it has changed. I have a sample of 20 and I have a test statistic of 45.6. I'm going to have a critical region on both sides. And I'm going to say that my critical region is 1.25% and 1.25%. From the table, I'm going to read a probability of 9875. 9875. I don't think that's there at the bottom. So 9875, that's 9875, 2.24. So my critical region is 2.24 and minus 2.24. So I'm going to use my test statistic and calculate its z value. Sigma is 30, sigma square is 38.2. 45.6 minus 42.4 divided by root of 2.31. So in the rejection region, therefore reject H naught. The mean time has changed. Okay. Question number 6, it says the height 8 centimeters of a random sample of 100 fully grown animals of a certain species with this find unbiased estimates of the population mean and variance. So H bar should be 57570 divided by 100, 75.7. And sigma square is basically 100 over 99 into 588050 divided by 100. 588050 divided by 100 minus 75.7 squared into 100 over 99. So I get mean 75.7, variance 152. Then it says calculate a 99% confidence interval. So for 99%, I'm going to take the z value as um, 2.576. So my confidence interval will be x bar 75.7 minus 2.576 into 151.525 into. So 75.7 minus 2.576 into 151.525 divided by. Okay, it's the correct answer. And it says four random samples were taken out in a 99% confidence interval for the population mean was found from each sample. Find the probability that all four of these contain the interval mu. So I'm going to say that the probability of the first one containing mu is 0.99, then 0.99, then another 0.99. So I'm successful in all four intervals. That should give me 0.96. Last question says customers arrive at a particular shop at random times. It has been found that the mean number of customers who arrive during a 5-minute interval is this 5-minute interval is 2.1. Find the probability that exactly four customers arrive during a 10-minute period. So lambda has to be 4.2. So e power minus lambda into lambda power 4 over 4 factorial. That's simple. 0.194. Okay, then it says find the probability that at least four customers arrive during a 20-minute period. So lambda is growing again. It is now 8.4. At least four means I want to calculate the probability of 0, 1, 2, and 3, and 4. So, sorry, at least four means this. At least four. So I need the probability of 4, 5, 6 up till infinity. So I'm going to say 1 minus probability of 0, minus probability of 1, minus probability of 2, and minus probability of 3. This becomes 1 minus e power minus 8.4 minus 8.4 e power minus 8.4 e power minus 8.4 into 8.4 square over 2 factorial minus e power minus 8.4 to 8.4 cube over 3 factorial. Zero point 0.968. Then the last one says use a suitable approximation to find the probability that fewer than 40 customers arrive during a 2-hour period interval. So this was for 5 minutes. During 2-hour intervals, I will have 20. This is a 20 minutes. So if I multiply this by 6, I should get the lambda for 2 hours. Since lambda is now large, I'm going to use an approximating distribution. I will first have to do a continuity correction. And use the same lambda as the variance as well. 39.5 minus 50.4 divided by root of 50.4. I get 3 less than minus 1.535. So minus 1.535. 1 minus 5 of 1.535. 0.9376. 0.9376. That's the correct answer. That's the end of the exam.